Imagine a place so far away that the sun looks like nothing more than a slightly bright star, no different from the millions of others scattered across the velvet black sky. This is the edge of our solar system. It is a place of absolute crushing silence. Here there is no wind, no sound, and no warmth. It is a graveyard of ancient rocks and frozen dust that have been floating in the dark since the very beginning of time. The cold here is not like a winter day on Earth. It is a deep penetrating freeze that stops everything in its tracks. The temperature hovers near absolute zero, a state where even atoms want to stop moving. In this region nothing ever changes. For billions of years the silence has been unbroken. It is a dead zone, a vast expanse of emptiness where the laws of nature suggest that everything should remain frozen solid and sleep in a slumber that is supposed to last forever. It is a place of loneliness so profound that it feels heavy pressing down on the emptiness of the void. Into this silent frozen theatre enters a wanderer. It is an object known to astronomers as 3I Atlas. At first glance it does not look like much. It appears to be just another dirty snowball, a jagged lump of rock and ice tumbling aimlessly through the dark. It is ancient and scarred, a traveller from the deep past. By all logical rules of space, 3I Atlas should be a cold dead rock. It is travelling through a region where the sun's energy is too weak to touch it. It is too far away to feel the warmth of our star. It should be as silent and frozen as the empty space surrounding it. But 3I Atlas is not asleep. Suddenly, without warning, the silence is shattered. Usually, comets only come alive when they get close to the sun. As they approach the heat, their ice turns into gas, creating the beautiful tails we see in the night sky. But 3I Atlas is nowhere near the heat. It is deep in the freezer of the solar system. Yet something impossible happens. The object begins to scream into the void. It is not a sound you can hear with your ears, but a violent explosion of matter. From the surface of this frozen rock, a massive jet of material bursts outward. It is not a gentle leak, it is a violent eruption. Imagine a firefighter standing in the middle of the darkest night holding a heavy-duty fire hose. He opens the valve all the way, and a powerful stream of water blasts out, pushing back against the darkness with tremendous force. This is what is happening to 3I Atlas. It is ejecting an incredible amount of material dust gas and ice particles out into the vacuum. Scientists calculate the volume and are left stunned. The object is spitting out 40 kilograms of dust and water every single second. To visualize this, imagine 40 bags of sugar or a large adult dog being thrown off the surface of this rock every time you snap your fingers. 1 second 40 kilograms, 2 seconds 80 kilograms. It is a continuous violent stream of matter pouring out into the nothingness. This image of the fire hose in space is terrifyingly beautiful, but it is also deeply confusing. It represents a massive contradiction. In the universe, energy cannot be created out of nothing. To melt ice, you need heat. To turn ice into gas, a process called sublimation, you need even more heat. But out here, there is no heat. Think of it this way to understand why this is so shocking. Imagine you have a refrigerator in your kitchen. You unplug it and you leave the door open. Eventually, the ice inside will melt because the room is warm. That makes sense. Now imagine you take that same unplugged refrigerator and you drag it to the South Pole in the middle of winter. You leave it outside in the snow where the temperature is minus 60 degrees. In that environment, the ice inside the refrigerator should never melt. In fact, any water you put in there should freeze instantly. It is physically impossible for the ice to turn into water or gas, because there is no energy to make that change happen. However, 3I Atlas is acting like that unplugged fridge at the South Pole, but somehow the ice inside it is boiling violently. It is acting as if it is sitting right next to a bonfire even though it is surrounded by the coldest temperatures imaginable. It is a dead zone where physics says nothing should happen. Yet here is this object acting with the energy of a living thing. This event creates a feeling of deep unease among those who observe it. It is not just a curiosity, it is a violation of the rules. We rely on the laws of physics to understand our place in the universe. We know that water freezes in the cold and boils in the heat. When we see something boiling in the freezing dark, it suggests that there is something we do not understand. Where is the energy coming from? Is there a fire burning deep inside the rock? Is it colliding with something we cannot see, or is the universe showing us that our understanding of impossible is wrong? The eruption of 3I Atlas is a lonely firework display at the edge of the world. It is a splash of chaotic motion against a canvas of eternal stillness. It churns out its 40 kilograms of matter per second, indifferent to the confusion it causes. It spins and sprays a mystery wrapped in ice, declaring loudly that even in the deepest, darkest void, nothing is ever truly dead. The silence has been broken, and the awakening has begun. To understand the sheer magnitude of what is happening right now with the discovery of 3I Atlas, we must first look in the rearview mirror. We cannot appreciate the rule breaker until we understand the rules that were established by the ghosts that came before it. The history of interstellar visitors, objects that come from outside our solar system, pass by the sun and then leave forever, is incredibly short. For centuries, these visitors were just mathematical ghost stories whispered by astronomers who dreamed of what might exist in the dark void between the stars. But in the last decade, theory became reality. Our first memory, a memory that is still fresh in the minds of every astronomer on Earth, is the arrival of Oumuamua. When it appeared on our sensors, it changed everything. It was the Scout, but it was a confusing Scout. Oumuamua did not behave like the comets we have known for thousands of years. When comets from our own solar system get close to the sun, they warm up. They release clouds of gas and dust, creating a beautiful glowing tail. This is how they speak to us. They shed their skin. But Oumuamua was Scout. It was dry. It was a stone-cold traveller that refused to speak. It had no tail, no cloud of gas, and no water vapour that we could detect. It was baffling. Based on how the light reflected off its surface, we realised it wasn't a round rock. It was elongated, stretched out like a cigar, or a flat pancake tumbling end over end through the darkness. It looked like a shard of a destroyed planet, a piece of wreckage from a cosmic accident. It felt dead ancient and incredibly mysterious. The most puzzling thing was that it accelerated slightly as it moved away from the sun, pushed by a force we couldn't see, perhaps the gentle pressure of sunlight pushing against its thin body, or perhaps jets of gas that were invisible to our telescopes. It left us with more questions than answers. It was a riddle wrapped in red weathered stone. Then, not long after, came the second visitor, Borisov. If Oumuamua was the mysterious stranger, Borisov was the familiar cousin. When Borisov arrived, astronomers breathed a sigh of relief because it made sense. It looked exactly like the comets we see in our own backyard. It was fuzzy, it had a tail, it was shedding gas and dust everywhere. Borisov was rich in carbon monoxide, a chemical that tells us it was born in a very cold, dark place far away from any star. It was a pristine snowball from the deep freeze of the galaxy. It proved that other star systems make comets just like ours does. It was a comforting confirmation that the laws of nature we see here on Earth apply elsewhere. We thought we had figured it out. There are dry rocks like Oumuamua, and there are icy comets like Borisov. We thought we had categorized the library of the universe. But then came 3I Atlas. This new visitor is why we are all awake tonight. 3I Atlas has shattered the categories we just built. It is the rule breaker. It does not fit in the box with Oumuamua, and it does not sit on the shelf with Borisov. It is something entirely different, something unique, standing alone in the spotlight of our telescopes. The difference lies in how it speaks to us. While Oumuamua was silent and Borisov shouted with dust, 3I Atlas is communicating through complex chemistry. It is not just shedding simple gas, it is leaking a chemical story that is far more intricate than anything we expected. When we break down the light coming from this object, a process that allows us to read the chemical composition of a distant object like a barcode, we aren't just seeing water or simple carbon monoxide. We are seeing a distinct exotic mixture that suggests this object was cooked in a very different kind of oven. 3I Atlas appears to be releasing heavy elements and molecular combinations that we rarely see in comets. It is as if this object has layers like an onion, recording the history of the star system it came from. It is not just a rock, it is a sample capsule. It is releasing gases that require specific temperatures and specific pressures to form conditions that might not exist in our own solar system. It is telling us that the recipe for making worlds is not the same everywhere. It is alien in the truest sense of the word. It is not dry like the first visitor, nor traditional like the second. It is a hybrid, a mutant, a complex traveller that carries the chemical fingerprint of a star that might be completely unlike our sun. This brings us to the poetic science of its movement. To understand 3I Atlas, you have to understand the road it is travelling on. In space, everything moves in curves. The Earth moves in a circle or an ellipse around the sun. This is a closed loop. We are trapped here happily by gravity. We go round and round, repeating our year over and over again. 3I Atlas is following a path known as a hyperbola. In the language of gravity, a hyperbola is the shape of freedom. It is the shape of a one-way ticket. A hyperbolic orbit means that the object is moving so fast with so much energy that the sun's gravity cannot hold on to it. It is not falling into a loop, it is falling through waving goodbye and carrying on into the infinity of the dark, and the speed is terrifyingly beautiful. This object is tearing through the fabric of our solar system at 130,000 miles per hour. To put that in perspective, that is vastly faster than a bullet, faster than any jet, faster than the rockets we use to leave Earth. At 130,000 miles per hour, you could travel around the entire Earth the 5 km/h, just upstairs. This speed tells us something profound about its origin. An object does not just wake up moving that fast. It gained that speed by falling through the deep wells of gravity between stars. It has been falling for a very, very long time. This is where the science becomes poetry. When we calculate the path of 3I Atlas, backward rewinding the clock, we see that it has been travelling through the empty void for millions, perhaps billions of years. It was likely ejected from its home system, kicked out by a giant planet or a dying star long before humans built the pyramids, long before the dinosaurs walked the Earth, perhaps even before the Earth itself had finished cooling from a ball of magma. Think about that for a moment. This object which we are looking at right now through our glass lenses was drifting in the silence of interstellar space while life on Earth was just single-celled organisms in the ocean. It has passed other stars, other worlds always moving, always sent until it accidentally crossed our path. It is a time capsule from an era we can never visit, sent from a place we will never see. It is a physical piece of forever. The message that 3I Atlas brings us is humbling. It teaches us that the universe is far more diverse than we dared to imagine. For a long time we assumed that if you have seen one solar system, you have seen them all. We thought that the recipe for stars and planets was standard. But Oumuamua was a shard of red stone. Borisov was a ghost of cold gas. And now 3I Atlas is a complex chemical laboratory moving at the speed of lightning. Each of these visitors is a separate chapter in a massive book that we are only just beginning to read. We used to think the space between stars was empty, a boring desert of nothingness. Now we know it is full of travellers. Some are dead rocks, some are icy comets, and some, like our new guest, are complex mysteries, carrying the ashes of dead fires and the seeds of strange chemistries. We are not looking at a pattern yet. We are looking at diversity. The universe is not printing copies of the same story. It is writing a different story for every star, and occasionally it throws a page of that story across the galaxy for us to catch. 3I Atlas is one of those pages. It is fleeting. It is fast. It is here for a blink of an eye in cosmic time, and then it will be gone, returning to the deep freeze, never to be seen by human eyes again. But while it is here, it is whispering secrets about how the universe is built using a language of chemicals that we are frantically trying to translate before it fades back into the dark. The summer of 2025 arrived on Earth with its usual heaviness, a blanket of heat wrapping the northern hemisphere. Down on the surface, the air shimmered above asphalt and cities hummed with the restless energy of millions of people. But far above the atmosphere in the cold vacuum of low Earth orbit, there was no heat, no sound, and no frantic movement. There was only the Neil Gehrels Swift Observatory, a robotic sentinel that had been watching the sky for decades. Usually Swift was a hunter of violence. It was designed to catch the screams of dying stars and the birth cries of black holes' gamma-ray bursts that illuminate the universe with the energy of a billion suns. But this summer, its instructions were different. It was not looking for a scream, it was listening for a whisper. It was not looking for fire, it was looking for ice. The object of its attention was the interstellar traveller that had slipped into our solar system. By the summer of 2025, the visitor was already on its journey back out into the dark, moving away from the warmth of our sun. To the naked eye, it was invisible. Even to many telescopes, it was nothing more than a fading ghost. But for the scientists operating Swift, it was the most important thing in the sky. They were hunting for the signature of water, the most precious substance in the cosmos. However, catching this signal was an exercise in excruciating difficulty. The team was trying to detect ultraviolet light. Unlike the visible light we see with our eyes, ultraviolet light is slippery. It is easily obscured, easily scattered, and easily lost. The Earth's atmosphere blocks it almost entirely, which is fortunate for our skins, but a tragedy for astronomers. That is why Swift had to be in space. But even in space, the challenge was immense. The sun was the primary antagonist in this drama. To find the comet, Swift had to look relatively close to the sun's position in the sky. Imagine trying to spot a single dying firefly while staring directly into the beam of a lighthouse. The sun produces a torrent of radiation, a thunderstorm of chaotic energy that floods the sensors. The signal from the comet was not a shout, it was a fragile, trembling note trying to survive in a hurricane of solar noise. The art of stacking finding the candle. To solve this problem, the scientists could not simply take a picture. If they took a single snapshot, the result would be a grainy wash of grey, static digital noise with no meaning. The comet was too faint and the background radiation was too high. Instead, they turned to a technique that is as much art as it is science, the process of stacking. Imagine you are standing on a mountain overlooking a sprawling metropolis at night. The city is ablaze with millions of streetlights, car headlights and neon signs. This is the background noise. Now imagine that somewhere in the centre of that blinding city, a single person is holding a birthday candle. Your task is not just to see the candle, but to analyse the colour of its wax. A single glance is useless. The city lights drown out the candle, but what if you took 1,000 photographs? In one photo, a random street lamp might flare up. In another, a car's headlights might sweep across the lens. The noise is random, it changes from moment to moment. But the candle is constant. It is always in the same spot, emitting the same faint glow. If you take those 1,000 photographs and lay them on top of one another, stacking them like sheets of transparent glass, magic begins to happen. The random noise cancels itself out. The flare of the street lamp in photo 1 is balanced by the darkness in photo 2. The chaotic static fades into a smooth grey background, and there in the centre the tiny constant light of the candle begins to emerge. It grows brighter and sharper with every layer you add. This was the daily ritual of the Swift team. They commanded the telescope to stare at the comet, taking exposure after exposure, capturing slivers of time. They were collecting photons, individual particles of light one by one. It was a process of agonising slowness. They were sifting through the digital sand of the universe looking for a few grains of gold. They were not looking for liquid water itself. In the vacuum of space, water cannot exist as a liquid. It is frozen as hard as rock. But as the comet approached the sun, that ice began to sublimate, turning directly from a solid into gas. Sunlight then struck those water vapor molecules, shattering them apart. A water molecule is made of 2 hydrogen atoms and 1 oxygen atom. When sunlight hits it, it breaks, often leaving a pair called hydroxyl, 1 oxygen and 1 hydrogen bonded together. This hydroxyl molecule, chemically written as OH, was the key. When it is bathed in sunlight, it glows with a very specific colour of ultraviolet light. It is a fingerprint. If you can see the hydroxyl, you know there was water, but the signal was faint. It was incredibly faint. Describing the difficulty, one could say it was like trying to hear a heartbeat across a crowded stadium during a rock concert. The thunderstorm of the sun's radiation was roaring, filling the data with static crashes and bangs. And yet through the stacking process, a pattern emerged. Slowly, pixel by pixel, the random noise was washed away and a small stubborn curve appeared on the graphs. It was the spectral signature of hydroxyl. It was the whisper in the thunderstorm. The post-it note from the stars. When the data was finally confirmed, the numbers were staggering in their scale, yet the implications were intimate. The team calculated that at its peak, the comet was shedding water at a rate of nearly 30 kilograms every second. That is roughly the amount of water in a standard bathtub lost to the emptiness of space every single heartbeat. Over the course of its journey through our solar system, the visitor had spilled oceans of water, leaving a trail of breadcrumbs that would eventually evaporate into nothingness. The discovery prompted Dennis Bodowitz, a key figure in this research, to make a statement that bridged the gap between hard science and human emotion. He described the comet and its water production as a post-it note from another solar system. This metaphor is profoundly beautiful in its simplicity. A post-it note is not a textbook. It is not a grand encyclopedia. It is a small temporary scrap of paper with a quick message scribbled on it. It is something you leave on a fridge or a desk for someone to find later. It implies a sender and it implies a receiver. What did this note say? It said, "We are the same." For centuries, humanity has looked up at the stars and wondered if our solar system is unique. We wondered if the special recipe that created Earth, the rocks, the gases and the liquids, was a freak accident that happened only here. Water is the most critical part of that recipe. On Earth, water is not just a chemical, it is the solvent of existence. It is the stage upon which the play of life is performed. Without water biology as we know it is impossible. It is the medium that allows nutrients to move, cells to divide and thoughts to form in our brains. Finding water on a comet from deep interstellar space changes the way we view the universe. If this visitor born around a distant and unknown star is made of the same ice that fills our oceans, then the ingredients for life are not unique to us. They are common. They are everywhere. The water detected by Swift was ancient. It was likely formed billions of years ago in the freezing nebula that birthed a star we will never see. It travelled through the silence of the void for eons, crossing distances that the human mind cannot truly comprehend, trillions upon trillions of kilometres. And yet chemically it was identical to the water that flows from a kitchen tap in London, or the rain that falls on the Amazon rainforest, or the tears we cry in moments of grief. There is a sacred geometry in this realisation. When the scientists looked at that jagged line on their computer screens, the line representing the ultraviolet glow of hydroxyl, they were looking at a bridge. On one side was the alien, the unknown, the terrifyingly vast dark of the galaxy. On the other side was the familiar, the domestic, the very stuff of our blood and cells. The detection of water turned the comet from a rock into a relative. It was no longer just a piece of debris, it was a carrier of the universal potential. It proved that the galaxy is not a dry, dead desert. It is a place rich with the potential for wet, messy, complicated life. The sacred solvent. As the summer of 2025 faded and the comet drifted further into the twilight of the outer solar system, the data remained. The whisper that Swift had caught was recorded forever. The scientific implications were technical. They learned about the ratio of gas to dust, the rotation of the nucleus, and the chemical erosion of the surface, but the philosophical implications were far heavier. Water is often called the universal solvent in chemistry because it can dissolve more substances than any other liquid. This allows it to transport chemicals, minerals, and nutrients, but in the context of the interstellar visitor water acted as a different kind of solvent. It dissolved the barrier between us and them. Before this, we could look at the stars and feel isolated, trapped on a wet blue marble in a universe of dry fire and cold rock. But the water signal from the comet washed that isolation away. It reminded us that the universe is hydrated. It suggested that if you could travel to that distant unknown star system where this object was born, you might find clouds and rain and perhaps oceans crashing against alien shores. The effort of the Swift Observatory, the struggle to look into the sun, the patience of stacking thousands of images, the hunt for the faint ultraviolet glow was an act of technological prayer. It was an attempt to touch the face of the deep cosmos and ask, "Are you like us?" And through the static, through the solar storms, through the vast distances, the whisper came back, carried on the back of a dying comet, "Yes, I am water. I am the same." In the end, the whisper in the thunderstorm was not just a triumph of engineering or data analysis, it was a reassurance. It told us that while the spaces between the stars are vast and lonely, the chemistry that fills them is familiar. We are made of star stuff, as the old saying goes, but we are also made of star water. And that water flows not just in our rivers, but in the veins of travellers passing through the dark, carrying notes from home that we are only just learning how to read. To understand why this celestial object behaves the way it does, we must first discard our traditional understanding of volcanoes. On Earth, a volcano is a mountain that blows its top because of molten rock or magma pushing up from deep underground. It is violent, hot, and driven by the shifting of heavy tectonic plates. But out here in the freezing darkness, nearly 3 times the distance from the Earth to the Sun, there is no magma. There is no fire. There is only ice rock and a silence that has lasted for billions of years. Yet at this specific distance, 2.9 astronomical units, something impossible happens. The object wakes up. To solve the mystery of the massive outburst that brightened this comet so suddenly, we have to look past the surface. We have to look inside. We must imagine this object not as a solid ball of hard rock like a marble or a granite boulder, but rather as something much more fragile and complex. Scientists have developed 2 fascinating theories to explain this: the rubble pile hypothesis and the Swiss cheese structure. Imagine you are building a castle out of dry sand and loose gravel. You pile it up high, but you do not pack it down tight. It holds its shape, but there are gaps everywhere. If you were to pour water into it, the water would not just sit on top, it would seep deep inside, filling thousands of little pockets and empty spaces between the grains. This is the rubble pile concept. It suggests that Comet 29P is not one solid piece of material. Instead, it is a gravity-bound collection of billions of rocks, ice boulders and dust grains that have drifted together over eons. They are holding hands loosely bound only by their weak gravity. Because it is a rubble pile, it is porous. It is full of holes. This leads us to the Swiss cheese model. Imagine a giant block of cheese that is filled with air bubbles and tunnels. Now imagine those holes are not empty. In the deep freezing vacuum of space, those internal caves and pockets are filled with super volatile ices, frozen carbon monoxide and nitrogen. These are gases that we are used to breathing or seeing as smoke on Earth, but out here they are frozen solid, locked inside the rock like a genie in a bottle. This structure is the key to the mystery. If the comet were solid, rock heat from the sun would just warm up the surface skin, but because it is a porous rubble pile, the heat or the pressure can affect the inside. However, at 2.9 astronomical units, the sun is too weak to melt water ice. So what is driving the explosion? This brings us to the concept of the warm heart. It is a strange thought to consider a frozen ball of ice as having a warm heart, but in cosmic terms, warmth is relative. We are not talking about a fire. We are talking about a faint simmering heat that comes from the beginning of time. When this comet was formed 4.5 billion years ago, it gathered radioactive materials elements like aluminum and potassium that naturally decay. As these elements break down over millions of years, they release energy. They release heat. Think of it like a compost pile in a garden. Even in the winter, if you stick your hand into the center of a compost pile, it feels warm. The decay of organic matter creates heat that gets trapped in the center. For our comet, the radioactive decay in its core acts as a slow-burning furnace. It is not enough the heat to melt rock, but it is enough to do something critical. It transforms the ice. Deep inside the comet, the water ice exists in a strange form called amorphous ice. This is ice that froze so quickly in the vacuum of space that its water molecules are jumbled and chaotic like a messy room. As the faint radioactive heat warms this ice, it tries to organize itself. It wants to become crystalline ice, where the molecules line up in neat, orderly rows. Here is the physics magic. When amorphous ice rearranges itself into crystalline ice, it releases heat. It is a chain reaction. The internal radioactive warmth triggers the ice to change shape, and that change releases even more heat. This heat has nowhere to go. The outer layers of the comet are a thick insulating blanket of dust and rock. The heat is trapped in the core. Now we have a problem. We have a warm core trapped inside a cold shell. We have pockets of frozen carbon monoxide and nitrogen hiding in the Swiss cheese holes. As the core warms up, these frozen gases sublime. They turn instantly from solid ice into gas. On Earth, if you boil water in a pot with the lid on tight, the lid eventually rattles. If you weld the lid shut, the pot explodes. Inside the comet, deep within the rubble pile, the carbon monoxide turns into gas. It expands. It wants to take up more space, but it is trapped in the tiny caves and voids of the Swiss cheese structure. The pressure builds and builds and builds. The comet begins to groan. This is where the object feels less like a rock and more like a living thing. It is under stress. The pressure inside the internal pockets pushes against the loose rocks of the rubble pile. The structure shifts. If you were standing on the surface, you might feel the ground tremble beneath your boots. You might hear deep, resonant cracks vibrating through the soles of your feet, sounding like the ice shifting on a frozen lake, but amplified 1,000 times. The comet is moaning under the strain of its own internal energy. The crust of the comet acts like a pressure valve that is stuck. It holds the gas back, struggling to contain the force building up from the center. But the comet is spinning, and it is traveling through space. The gravitational tug of Jupiter, even from a distance, pulls at it. The heat from the internal crystallization pushes out. The gas pockets swell. Then the breaking point arrives. It does not happen as a single clean explosion like a cannon shot. Because of the Swiss cheese structure, the eruption is complex. A weak spot in the crust gives way. Perhaps a small landslide on the surface thins the roof of an underground cavern. Instantly, the pressurized gas finds a way out. This explains the why of the violence. The gas isn't just drifting away. It is being pushed out by massive accumulated pressure. But here's the fascinating part of the Swiss cheese hypothesis. It is rarely just one hole. When one pocket ruptures, the shockwave travels through the loose rubble pile. It shakes the neighboring pockets. It causes the fragile walls between the cheese holes to collapse. Suddenly, a network of thousands of small vents opens up all at once. Imagine a shaken soda can. If you poke one hole, it sprays. But imagine if the metal of the can was weak and poking one hole caused 100 other tiny holes to rip open right next to it. The surface of the comet fractures. This is why the eruption is so powerful and so bright. It is not a single chimney letting out smoke. It is a catastrophic failure of a large section of the landscape. Thousands of micro vents activate simultaneously. They scream into the vacuum of space, blasting out jets of carbon monoxide gas. But the gas does not travel alone. As it rushes out of the dark, pressurized caves, it drags the loose rubble with it. Dust pebbles and chunks of ice are ripped from the interior and thrown into space. This material forms the massive glowing cloud, the coma that astronomers see from Earth. The comet effectively vomits out its own insides. This imagery changes how we view the object. It is not a passive traveller. It is an active dynamic engine. It is a steam engine where the boiler is the radioactive core, the steam is carbon monoxide gas, and the pistons are the shifting plates of the crust. It is a machine that has been running for billions of years waiting for the pressure to reach the red line. The living aspect of this hypothesis is crucial. A solid rock is dead. It only changes if something hits it. But this comet changes from the inside out. It evolves. Every time it erupts, it reshapes itself. The surface collapses into the empty pockets left behind by the escaping gas. New cliffs form, new cracks open. The landscape is constantly being rewritten by these violent exhalations. Furthermore, the Swiss cheese model explains why the outbursts are unpredictable. We cannot see where the gas pockets are hidden under the surface. One orbit, the comet might remain quiet because the pressure is contained. The next orbit, the heat might reach a massive reservoir of trapped nitrogen, triggering a super outburst. It is a game of Russian roulette played on a planetary scale. The distance of 2.9 astronomical units is significant because it might represent a thermal tipping point. Even though it is far from the Sun, it is the boundary where the solar warmth is just enough to soften the outer crust, making it slightly more flexible, slightly less brittle. This slight change in the crust's properties combined with the intense internal pressure creates the perfect storm for these rupture events. The interaction between the rubble pile structure and the internal pressure also explains the duration of the eruptions. These are not instantaneous pops. They can last for days or weeks. This suggests that once the vents open, they stay open for a while. The comet spends days exhaling, blowing off the accumulated stress until the pressure inside drops back down to a manageable level. The crust then settles, the rubble shifts to plug the holes, the seal reforms, the comet goes back to sleep, and the cycle of pressure build-up begins all over again. This constant cycle of tension and release makes the comet feel like a breathing organism. It inhales heat both from the faint sun and its own radioactive core. It holds its breath as the pressure builds, and then it exhales violently when it can no longer hold it in. Understanding this mechanism transforms our view of the outer solar system. It tells us that the cold, dark reaches of space are not static. They are filled with these sleeping giants, these ancient steam engines that are slowly digesting their own primitive fuel. Comet 29P is a laboratory that shows us how the raw materials of our solar system behave when they are left alone to cook in the cold for eons. The rubble, pile, and Swiss cheese theories also give us a clue about how dangerous or fragile these objects are. If we were to try to land a spacecraft on this comet during a quiet period, we might find the ground treacherous. It would not be like landing on the moon. The surface might be like a crust of hard snow over a deep pit of soft powder. A probe could sink, or worse, its landing thrusters could heat up a hidden pocket of gas just below the surface, triggering a man-made eruption that blows the spacecraft back into orbit. In summary, the violence of the eruption at such a great distance is not a contradiction. It is a consequence of structure. It is the inevitable result of a porous, fragile body trying to contain the energy of a billion-year-old radioactive heart. The thousands of vents working in unison create a force far greater than any single volcano could achieve in such low gravity. The comet is a masterpiece of natural engineering, a self-regulating pressure vessel that has survived since the dawn of the solar system by periodically tearing itself apart to stay alive. This connects deeply to the idea of the luminous fog we discussed earlier. The fog is not just a cloud, it is the breath of the comet. It is the physical evidence of the internal struggle between the heat trying to escape and the rock trying to keep it in. Every time we see that brightness flare up in our telescopes, we are witnessing the heartbeat of a lonesome traveller, proving that even in the deepest freeze of space there is still energy, there is still movement, and there is still life in the geology of the stars. The Red Planet's Vigil. It is October the year 2025. The solar system is usually a clockwork mechanism of predictable silence, but this month the rhythm changes. The stage is set around Mars, the fourth rock from the Sun. For billions of years, Mars has been a lonely, rusting world, its atmosphere stripped away by solar winds leaving behind a cold desert landscape. But in this specific moment of history, Mars is not alone. It is surrounded by a halo of human technology. Dozens of satellites and orbiters circle the red planet. They were built to look down, to scan the red dust, to search for ancient riverbeds, and to listen for the whispers of seismic activity. But today the commands sent from Earth have rotated them. They are no longer looking at the ground, they are looking up. The object 3I Atlas is approaching. This is not a collision course, but it is a cosmic grazing. In the vastness of space, a distance of a few million kilometers is intimate. It is close enough to feel the presence of the visitor. The spacecraft orbiting Mars NASA's MAVEN, the Mars Reconnaissance Orbiter, the European Space Agency's Trace Gas Orbiter, and the HOPE probe from the United Arab Emirates form an unplanned welcome committee. They are the silent witnesses to a historic flyby. The anticipation in the control rooms back on Earth is electric, but on orbit there is only the cold vacuum. The machines wait. They orient their solar panels to catch the light, and they aim their high-gain antennas and spectrometers toward the deep black patch of sky where the visitor will emerge, the veil of plasma. As 3I Atlas draws closer to the orbit of Mars, it reveals that it is not merely a dead rock tumbling through the dark. It is alive with energy. The most striking feature observed by the Martian sentinels is not the solid surface of the object, but the invisible shield that it carries with it. The sensors on the MAVEN spacecraft, designed specifically to study the atmosphere and magnetic environment, begin to scream with data. They detect a massive turbulent sheath of plasma. Plasma is the fourth state of matter, a superheated gas where the electrons have been ripped away from their atoms. The sun constantly blows a stream of this charged material outward, known as the solar wind. Usually comets interact with this wind passively, creating a long flowing tail. But 3I Atlas is different. It is dense, and it possesses a strange intrinsic magnetic quality. When the solar wind slams into the magnetic field surrounding 3I Atlas, it creates a shock wave. It is similar to the bow wave created by a ship moving fast through water. This bow shock glows brightly in the ultraviolet spectrum. The charged particles are trapped spiraling along invisible magnetic lines that wrap around the object like a protective cocoon. The Mars orbiters detect that this cocoon is pulsating. It expands and contracts, breathing in the solar wind. The data shows that the magnetic field strength around the object is significantly higher than expected for a standard comet. It suggests that the core of 3I Atlas contains metals, perhaps iron or nickel, conducting electricity and generating a shield that fights against the sun. To the sensors, the object looks like a ghost wrapped in a storm. The plasma sheath is hot, chaotic, and crackling with electromagnetic noise. It disrupts the smooth flow of the solar wind, creating a wake of turbulence that stretches out for hundreds of thousands of kilometers behind it. Mars, passing near this wake, experiences a slight ripple in its own thin upper atmosphere, a phantom touch from the traveller. The contrast of worlds. The visual contrast captured by the cameras is poetic and stark. In the foreground of the images sent back to Earth, we see the curved limb of Mars. It is a burnt orange, dusty and dry. It is a planet that lost its water billions of years ago, a fossil of a world. In the background, hanging in the black void, is 3I Atlas. Spectroscopic analysis confirms what scientists had hoped: this object is rich in volatiles. It is heavy with water ice, ammonia and methane. It is a frozen reservoir of the very things Mars has lost. It is a cruel irony of orbital mechanics. Here is a visitor carrying oceans worth of potential water flying past a world that is dying of thirst. The silent witnesses. The satellites capture this duality. They see the arid, cratered surface of the red planet and the glistening, icy coma of the visitor in the same frame. The sunlight catches the sublimating gases from 3I Atlas. As the object heats up near the orbit of Mars, jets of steam and dust burst from its surface. These jets catch the solar light, creating a halo that rivals the brightness of the stars. For a brief window of time, it looks as though Mars has a second smaller moon, but one that is fuzzy and wild, untamed by gravity's long-term lock. The data suggests that if this object were to hit Mars, it would be a catastrophe, but it would also be a rebirth. It would deliver enough water and gas to thicken the atmosphere and fill low-lying craters, but the laws of physics are strict. The object is moving too fast to be captured. It is just a tease. It parades its life-giving water past the dead desert and continues its rush toward the sun. The view from the dark, the JUICE mission. While the eyes of Earth and the orbiters around Mars are fixed on the spectacle, there is another witness far more lonely and distant. This is the Jupiter Icy Moons explorer known as JUICE. Launched by the European Space Agency, JUICE is on a long, lonely cruise to the outer solar system. Its destination is Jupiter, where it will study the giant planet and its frozen moons. But in October 2025, JUICE is still in the transit phase, floating in the deep expanse between the orbits of the inner planets and the gas giants. JUICE is positioned on the other side of the solar system relative to the Mars encounter. From its vantage point, the sun is a blazing obstacle and the angles are difficult. However, this unique position offers a perspective that no one else has. While Earth and Mars see the face of 3i Atlas illuminated by the sun, JUICE sees the side profile and the night side. It observes the object against the backdrop of the solar corona. This part of the mission is a lesson in patience. The team operating JUICE knows that they are working with extreme latency. The distance is so vast that radio signals travelling at the speed of light 300,000 kilometers per second take many minutes, sometimes nearly an hour, to make the round trip. There is no live control. There is no joystick to move the camera. The commands to observe 3i Atlas were uploaded weeks in advance. The spacecraft is executing a pre-written script. It turns its massive solar arrays, adjusts its high-gain antenna, and points its remote sensing instruments into the void. The concept here is delayed gratification. The scientists back in Darmstadt, Germany sit at their consoles, but their screens do not show what JUICE sees right now. They show only the carrier wave, the heartbeat of the spacecraft confirming it is alive. They must wait. They must trust the math. They must trust that the spacecraft is looking at the right coordinate at the exact right second. The geometry of silence. The silence around JUICE is profound. It is far from the magnetic noise of Earth and the dust of Mars. In this clean, cold vacuum, JUICE's sensors pick up the subtle interactions of 3i Atlas with the interplanetary medium. Because of its angle, JUICE can measure how the sunlight scatters through the dust tail of the object. This is crucial. By looking at how the light is broken up and dimmed by the tail, scientists can determine the size of the dust grains. Are they fine like cigarette smoke, or are they coarse like beach sand? JUICE also carries a magnetometer. Even from this great distance, it searches for the ripple effects of the object's magnetic disturbance travelling through the solar wind. It listens for the magnetic wake that might propagate outward like ripples in a pond. The data is stored on the spacecraft's hard drives. It sits there, a digital treasure chest, while the spacecraft prioritizes keeping its systems safe. Only when the observation window closes does JUICE slowly turn its antenna back toward Earth to begin the download. The download is slow. The bitrate from deep space is not like a fiber optic connection. It is a trickle. Bit by bit, the image builds. First a grainy grey pixelation, then the stars, and finally the smudge of the intruder. The intersection. For a few days in October, the solar system feels smaller. The geometry of the orbits has created a perfect triangle of observation. At one point, Earth-Mars and the object align in such a way that radio signals sent from Earth to the Mars orbiters have to pass through the tail of 3i Atlas. This is a happy accident of celestial mechanics. As the radio waves pass through the coma and tail, they are distorted. The frequency shifts slightly, the signal strength wavers. Radio science teams on Earth use this interference to weigh the comet. They measure how much stuff the radio waves had to push through. It is a way of touching the object without ever landing on it. They can hear the density of the dust and gas in the fading strength of the radio signal. The contrast between the frantic data collection and the physical reality is sharp, and in space there is no sound. The plasma bow shock, which would roar like 1,000 thunderstorms if it were in an atmosphere, is silent. The massive jets of steam venting from the surface are silent. The passage of a mountain-sized object at 30 kilometers per second is silent. The only noise is the hum of cooling fans in the server rooms on Earth and the clicking of keyboards as scientists race to process the raw binary code streaming down from the heavens. The departure. As October ends, the encounter concludes. 3i Atlas does not slow down. It respects no borders. It crosses the orbit of Mars and dives inward toward the perilous heat of the sun. The Martian satellites, having completed their watch, receive new commands. They spin back around. Their cameras point down once more at the rust-coloured canyons and the polar ice caps of Mars. They return to their routine work of mapping the weather and searching for methane spikes on the surface. The visitor is gone from their field of view. JUICE continues its long, lonely fall toward Jupiter. The data it collected is beamed back, verified and archived. The spacecraft returns to its hibernation state, saving energy for the years of travel still ahead. The encounter leaves no physical mark on Mars. The red dust is undisturbed. The thin atmosphere settles back into equilibrium. But the digital memory of the event is permanent. The silent witnesses have done their job. They have captured the ghost in the machine. We have learned that 3i Atlas is not just a rock. It is a magnetic anomaly. It is a shielded world. It is a water bearer. And as it moves closer to the star at the centre of our system, we know that the real show is only just beginning. The heat is rising, and the silent witnesses have passed the baton to the solar observatories that are waiting for the final act. As the great traveller moves away from the warmth of the sun, the brilliant tail that once painted the sky begins to fade. The show is over. The ice stops turning into gas, and the magnificent white cloud that surrounded the rock settles back down into silence. It is no longer a glowing spectacle. It returns to being a silent wanderer, a lonely stone drifting back into the deep cold ocean of space. There is a feeling of a sadness as we watch it go, like saying goodbye to an old friend who visited for just a brief moment. The light grows dimmer and dimmer, shrinking until it is nothing more than a faint speck against the velvet black curtain of the universe. Eventually it vanishes into the shadows, returning to the frozen out edges where time seems to stand still. But even though it is gone, it has not left us empty-handed. In the quiet dark there is a beautiful secret. This departure is not an end. It is part of a cycle that has existed for billions of years. As the object fades into the eternal night, we are left with a sense of hope, a realization of what these travelers actually do. Think for a moment about the darkness of space. It is not empty. It is filled with tiny grains of dust, floating particles, and ancient rocks. For a long time we looked at these icy visitors and thought they were just debris, the leftovers from when the planets were built. We thought they were accidents. But now we see them differently. We see them as the gardeners of the galaxy. This brings us to a profound idea. Imagine the early universe as a vast, empty field. It was waiting for something to grow, but the planets were dry and barren. Then came the comets and the asteroids. They were not just rocks crashing into worlds. They were vessels. They were cargo ships carrying the most precious treasure in the existence of time, the ingredients for life. Inside the frozen heart of these wanderers lies water. The same water that fills the oceans of Earth, the same water that falls as rain, and the same water that makes up your body. It is believed that long ago, when Earth was young and hot, it was these celestial travellers that crashed down delivering their ice. They melted and formed the first seas. They brought the water that would one day become the home for the very first heartbeat of life. But they brought more than just water. They carried simple organic compounds. These are the building blocks, the tiny chemical seeds that nature uses to build living things. They carried carbon, the element that anchors all life as we know it. They carried the basic parts that would eventually become proteins and cells. This is the concept of the cosmic seed. It suggests that life did not just magically appear from nothing on one lonely planet. Instead, the potential for life is sprinkled throughout the stars carried on the backs of these silent travelers. They wander through the galaxy, passing by the solar systems, dropping off their cargo of water and chemistry. They are the bees of the universe, pollinating the planets with the possibility of existence. So when you look up at the night sky, you are not looking at a stranger. You are looking at your ancestors. You are looking at the source of the atoms in your blood and the calcium in your bones. This realization changes everything. It means that we are not isolated. We often feel small when we look at the stars. We feel like tiny specks on a rock separated from the rest of the universe by millions of miles of cold vacuum. But the chemistry tells a different story. The chemistry tells us that there is no separation. The boundary between you and the stars is an illusion. The iron in your blood was forged in the center of a dying star. The oxygen you breathe was created in the fiery breath of a supernova. And the water you drink was delivered by a comet that traveled billions of miles to reach you. You are made of the same stuff as the galaxies. You're quite literally stardust that has come to life. This is a comforting thought to hold on to as the day ends. We are not alone. We are not chemically lonely. We are part of a massive invisible web that connects every planet, every moon, and every living being. We belong here. We fit perfectly into this design. As the celestial body disappears completely into the void, allow yourself to drift with it. Imagine that you are weightless, floating gently in that vast, quiet space. There is no noise here. There is no rush. There is only the slow, rhythmic breathing of the universe. The cold of space is not scary. It is peaceful. It is a stillness that rests the mind. Just as the comet returns to its long sleep in the darkness, you too can return to rest. The energy that fueled the comet's journey came from the sun, and now that it's far away, it can cool down. It can stop working. It can simply be. You have used your energy today. You have shone your light. And now, like the traveller, you are moving into the gentle shadow. It is time to let the dust settle. It is time to let the mind become quiet and dark like the peaceful edge of the solar system. Feel the connection you have to everything around you. You are safe in this universe because you are made of it. The stars are your distant cousins. The comets are the bringers of your life. You are held by gravity, protected by the atmosphere, and comforted by the knowledge that you are exactly where you are meant to be. The legacy of stardust is not just about science, it is about belonging. It is the story of how the universe woke up and looked at itself through your eyes. You are the universe expressing itself as a human being for a little while. So let go of the worries of the day. They are small compared to the majesty of the stars. Let them float away like dust in the solar wind. Let them dissolve into the vastness. Close your eyes and see the velvet blackness. It is soft and wrapping around you like a warm blanket. In this darkness there is potential for dreams. In this darkness there is recovery. The traveller has gone to sleep in the deep dark. The stars are watching over you steady and bright. You are connected to all of them. You are a child of the cosmos drifting safely on this blue marble, spinning gently through the night. Drift deeper now. The journey is over for today. The silence is here. You are stardust, and to the stars you return in your dreams. Sleep well.